we are continuing with the second tutorial, and we are still doing quiz 4, but this is the last part of this tutorial. So this is question 2A for section 20. What are ceramics? What are their main properties? Name some traditional and engineering ceramics. A very basic question, and especially when you are doing a quiz on only 1 or 2 chapters, and each chapter is only partially done. So the definitions which you know from chapter 1 also, and we have revised it again. So let's go ahead. The definition: ceramics are inorganic and non-metallic materials bonded together by ionic or covalent bonds. Right, so this is important, that ceramics, unlike say alloys are mixtures of materials, but these are bonded. And further definition, that generally there is one metal part and one non-metal part in a ceramic, and ionic or covalent bonds. Then what are their major properties? We are not listing all of them, but good electrical and heat insulation. Remember, opposite of conduction. Right? They are bad conductors of heat and electricity, so they are good insulators. They are hard and brittle. Hard means they are also very strong. Brittle, they break without much deformation. Lesser ductility and toughness than metals. This is automatic extension of brittle. Compared to metals, they are less ductile and less tough. They have high chemical stability, which is very important. It is difficult for other materials to easily react with them, and they have high melting temperature, which is one of their most important properties. So out of all of them, their strength and hardness is very high, even compared to metals, and they have a very high melting temperature. So these are their best properties. Traditional ceramics, the basic components are clay, silica, feldspar, and examples of traditional ceramics: glasses, bricks, construction tiles, electrical porcelain, and so on. Similarly, then, the advanced or engineering ceramics, they are generally made from pure compounds. So aluminum oxide, which is generally known as silica, silicon carbide, silicon nitride, and say these are more modern ceramics. So this was very basic, and I think everybody should be very easily be able to handle this, because at the end of the full course on material science, we can easily define what is a ceramics and what are their major properties and some of their major kinds. With that, we move to the last question of this tutorial, the second part, question 2B of section 20, the solution numerical type of question part. So let's see. Calculate the density of cesium iodide, which has the cesium chloride structure. Ionic radius cesium 0.165 and iodine ions 0.220 nanometers. Mass cesium 132.9 and iodine 126.9 gram per mole. A very, very basic, simple question. Really making it easy for the students to score, because this is exactly the type of example that we have solved in the class, and finding the density is very basic, right? So even if, as I keep on saying, that you see, if you want the tutorial to be of real value to you, then pause the lecture here, right, this tutorial lecture, and solve this. You have solved it earlier, but now the problem is there. Solve it yourself on a rough piece of paper, and be very confident that you are sure that your question answer is right. Then click and go on and listen to the solution and so on, right? That is always that in every solution that we did in class examples and in homeworks everywhere. Look at the problem, hide the solution, don't give up, take it as a challenge, solve it completely yourself. Once you are 100% satisfied that you are happy with your solution, then look at the solution and compare. If you have done correctly, then give yourself a pat on the back, be very happy. If you had done some error, then note down exactly what was your error, and once you yourself realize your error, then hopefully you will not repeat it in any quiz or exam and so on. Okay, so before I show you the solution, right, it is simply, what is density? Density is mass per unit volume. Density is mass per unit volume. Because every ceramic is a crystal, right? So we know cesium chloride crystal structure, it was the simplest one. Cesium chloride crystal structure. For the cesium chloride crystal structure, was it a BCC, was it an FCC, how was it there, and so on. So when you say mass per unit volume, then in a unit cell, how many total atoms of cesium and iodine were there? How many? And you find the total mass of all of the ions or atoms of cesium divided by the volume of the cube. It is very simple. It is a unit cell. So unit cell is a cube. So what is the volume of the, volume is A cubed. But is A is equal to 4r upon root 3 or 4r upon root 2 or A is equal to 2r plus 2r? Those things you will have to see. So that is it. All the values are given. The radii of the two ions are given. The masses of the two are given. Avogadro's number you know, right? So let us see, right? Root 3a is equal to 4r, right? That is there for the general BCC type of structure, which it is. But instead of 4r, we have 2 small r plus 2 large r. That is it, right? We have done this in the example for BCC type of structures, which is the structure of cesium chloride, which cesium iodide has a similar structure to. Root 3a is equal to 4r if it was a pure substance, but if it is a small r and large r, then root 3a is equal to 2r plus r. Now small r is given, right? Big R is given, both r's are given. A is equal to 2 upon root 3 into this, just put in the values. A is now found. Now you can leave this A as a nanometer, but remember, when we find density, the standard units of density are either kilogram per meter cube, or gram per cubic centimeter. So because the masses are already given in gram per mole, so when you use the Avogadro's number, these will convert to grams. So the only thing you need to do is convert the nanometer into centimeter, and that's it, because the difference between a nanometer and centimeter is 10 raised to minus 7, right? 10 raised to minus 7. It is 0.445. So 4.45 10 raised to minus 8. It is a very, very simple conversion. So you have already done this in centimeter. So now when you find the volume, it will be in centimeter cube. So the units will be totally right, gram and centimeter cube. So this is A and the volume is A cubed, right? This is A, the volume is A cubed. Now what is the mass? What is the mass? In BCC, there are 2 equivalent atoms. 2 equivalent atoms in a BCC. Because this is a ceramic, so there is 1 cesium and 1 iodine, and that's it. So not 2, because 2 would be for 1 material. So 1 cesium, 1 iodine, the masses are there. Divide them by the Avogadro number. This is the total mass of the unit cell. And volume is, density is mass per unit volume. So mass upon A cubed. This is the mass. And this was in cubic centimeter directly. So cube this, and whatever answer you get after solving this is directly gram per cubic centimeter, right? And that's it. And that's it. When you are in a quiz, of course, you just stop here. When you are at home, you just go to the internet and type density of cesium iodide. Density of cesium iodide. If they tell you that this is roughly 4.9, then you should be very happy that I have found the density at the crystal level. But this is equal to the actual experimental density of the material. So this is it, guys. We have finished the tutorial, because as I said, we are not including the solution of the midterm, as all the chapters which were covered in the midterm are now not part of the final exam. So quiz 3 and quiz 4 have got enough examples, and especially when there are 2 sections, right? So we have finished the tutorial. Now just some guidelines for you, that please solve all the examples that we have done during the class. Again, all the quizzes we have solved with you together, solve them again. But here I am saying further practice. Further practice means that if you have done all the class examples and all the quiz solutions and so on, then now solve all the homework problems for chapter 4, 8, 9, 10, 11, which are the coverage of the final exam, right? But the word independently, right? I mean, if somebody else solved it for you and you have just submitted the homework, it does not serve any major purpose for you. So even if you took the solution from someone else, hopefully you, especially who are listening to me, have done yourself independently. But even if you took it from somebody, now resolve each of the homework problem independently. And once you are sure of your solution, then go back and compare your solutions, right? So class examples, quiz solutions, and homework problems. Anybody who does all this is seriously above average already, right? Carefully revise all lab work and lab reports, because you know that questions from labs will also be coming on your final exam. And then people who want to be really A- type of students, solve some selected problems only. Don't solve all of the problems, only the more difficult problems given at the end of the chapters. For chapter 4, chapter 8, chapter 9, chapter 10, chapter 11, go to the end of the chapter and see. Don't solve all the problems, just read the problems. If they are very easy, don't solve them. If you find, oh, this looks to be a tough problem, then solve it. So right, this is always for any course, I would always suggest the same thing, that revise all the examples done in the class very carefully, revise the solutions of all the quizzes and exams that you have done until now very carefully. If the lab is including, do that. Homework problems are there basically for practice, so do the homeworks again for the chapters. And finally, if you want to be really top of the class, then do a few extra problems which are from the end of the chapters and which are more tough than usual. So we are done with the tutorial. All the best for your final exams, not just in my course, but in all the other courses. And if you have any further questions or something for me, you know my office. If you don't find me there, you know my email, and we can contact, and we can go through any solutions or any explanations that you would like to do. Thanks a lot once again. It was a great experience to be with you during this course. Hopefully the course was both interesting and challenging for you, and hopefully you will get a very good grade in the end. Thanks and ma'as salama.